going to test this. So you're going to see. I'm just going to click. All right. Welcome, everybody. Thank you for coming. My name is Eric Maynard. I'm an engineer at Snowflake, where I work on Apache Iceberg, Apache Polaris, and related projects. Rahil works at OneHouse on XTable and other things, but unfortunately, he couldn't be here with us in China today. So my presentation is called Apache Polaris and Apache XTable, Unifying Iceberg, Hudi, and other table formats. I'll try to explain what that means, but first, I am going to introduce the Iceberg REST catalog. Many of you probably already know a lot about Iceberg, so that might be a review. I will then tell you a bit about Apache Polaris, which is an implementation of the Iceberg REST catalog. I will talk about a feature called generic tables in Iceberg, or rather in Polaris. I'll talk about XTable a bit, and then I'll outline some of the future work that Rahil and I are working on right now. Hopefully we'll have time for the questions at the end. I tend to talk fast, so if you don't understand something or if I go too quickly, please feel free to raise your hand and interject. So first about Iceberg and the REST catalog. So this is Iceberg in a nutshell, right? You have a metadata file, which we often call the metadata.json, that tells you things like the number of records in a table, tells you things like the properties of the table, and it points at these manifest files. Each of these then in turn eventually direct the client to data files, which are typically Parquet files, although they could be some other format. And with all of these things, you can say that you have an Iceberg table, just looking at the table part of the Iceberg project, the table specification. However, in practice, you need a way to actually read this data with your Spark job or your Flink job or whatever else. And so we have the concept of a catalog. And in the very early days of Iceberg, the client would essentially be responsible for translating a query like select star from db1.table1 into a metadata.json file. And so the way that this was done is usually you would create a warehouse, which was like a location in object storage, like S3, and then the client would have some way to do that conversion. Usually the db1 was a folder, and then table1 was another folder, and you would resolve the path that way. This is not a good idea, right? Because you may have tables that don't fit this structure. There's also a lack of governance. So you just have clients randomly modifying object storage. They may try to modify the same table concurrently. They may do things they're not supposed to with that data. And you, as an administrator of a lakehouse, have no way to control that. There are also performance concerns. So every time the client wants to query that data, they have to kind of traverse this entire graph of metadata repeatedly. And especially for streaming jobs, this is a big performance problem. There are also compatibility concerns. So you can see here that the engine or the client takes on the responsibility for writing the data files, the manifest list, the metadata, and so forth. And so it could be that one client writes metadata that another client doesn't know how to read, and then all of a sudden your table is broken. And so Iceberg quickly introduced the concept of a catalog. And so what we call a traditional Iceberg catalog is something like a Hadoop catalog or a Hive catalog. And this brought a lot of benefits to using Iceberg. You have identifier-based addressing. So catalog is like a Java interface, for example, that has a method that says, I'm going to give you an identifier, so db1.table1. Please give me back a metadata file. There are also opportunities for governance because all of the clients are coming through this catalog. You have ways to restrict who has access to what data. You could, for example, have a lock on each table so that only one client can write each table at a time. So the traditional Iceberg catalog solved some of the problems with Iceberg, but it didn't solve all of them, right? We still have to load that metadata in the client. We still have compatibility concerns. And it's also very difficult to implement your own client because you have to write a client that knows how to read data files, knows how to read manifests, manifest list, and metadata.json. So where is Iceberg trending? We now have the Iceberg REST catalog, which is a specification in the Iceberg project. In addition to the benefits we had before, with identifier-based addressing and the opportunities for governance. In the Iceberg REST catalog, the catalog itself takes on the responsibility for writing the metadata files. So what this means is that the catalog can cache the metadata file, it can compress them, it can fragment them, it can store them however it wants. It's just responsible for implementing a REST API. This also ensures consistent metadata format. So you don't have to worry about breaking your table with some weird client because the REST catalog is responsible for managing. So you can see the catalog is kind of coming down the stack a little bit here. And it's much easier to write an Iceberg client today than it was in 2022 because you don't have to handle metadata files. You only have to deal now with that lower part of the stack. And in fact, this trend is continuing. If you follow Iceberg, if you follow the proposals, you can see that in the future we may even be in this state. There's proposals around metadata tables that only exist in the catalog. There are proposals around fine-grained commits where you can just add data. You don't have to touch any metadata files as a client. There's simplifications for load table. There's fine-grained access control and scan planning. So there's lots of features that mean the catalog is taking on more and more responsibility within the Iceberg ecosystem. And so with that context, I want to introduce Apache Polaris. This is like a official marketing slide, so I'm sorry that it doesn't match the colors that we have today. But Polaris implements the REST catalog specification. So there's about maybe, I don't know, 20 APIs like load table, list tables, drop table, and so forth. Polaris implements those APIs. But Polaris also implements some extra APIs. And I guess I should note at this point, by the way, that there are many implementations of the Iceberg REST catalog. I know Gravitino is here today with some great talks. They're a fantastic implementation of the Iceberg REST catalog. There's also Unity catalog from Databricks, which partially implements the IRC spec. There's lots of startups like Lakekeeper. So Polaris is not the only Iceberg REST catalog, but I'm here today to talk about features in Polaris. So what are the other APIs that Polaris has on top of the REST spec? You can create policies. So you can create a table compaction policy that says, every day I want to ensure that the average file size is greater than 16 megabytes. And then you can configure compaction to run against the tables which you attach that policy to. You have access management. So I'll talk more about this later, but basically you can restrict who can see which data. You have the ability to federate to other catalogs. I'll talk more about that. You can also use an external identity provider. So this kind of works hand in hand with access management. Basically, if you have all of your users in something like Okta, you can ensure that only certain groups can access certain sets of data. And again, we're going to talk about this later, but another feature in Polaris is generic tables, basically non-Iceberg data. But before we talk about generic tables, I want to back up a bit and talk about what a typical lakehouse looks like. We'll talk a little bit about access management, and then we'll see how this fits in with the topic of today's conversation. So first off, when you connect to the catalog, you need to authenticate. So you call the REST API, and you need to prove your identity to the catalog. Polaris can function as an OAuth 2 server. So when you create users, it spits out an ID and a secret. And if you provide that ID and secret back at a later time, you can get a token. Polaris can also federate to a third-party authentication server. So again, if you have Okta or something like that, you can use it. Once you've obtained your token and you've proven your identity, in order to get you access to data, we then need to look at what roles you have. So in this example, this happy user maybe has the engineer role, and maybe they also have the data engineer role. Each of those roles that the individual has are connected to catalog roles, which are essentially groups of privileges. So maybe engineers can read logs, and maybe data engineers can create pipelines. For each of these, you can assign multiple grants. So maybe there is some namespace called, I don't know, logs public. Maybe can read logs gives you access to that. And then maybe for pipeline authors, you get create table and maybe drop table on an entire catalog. So that's essentially the mechanism by which you can control who can access which data. You attach roles, and then you give grants on those roles. So let's look at a typical, simplified lake house that you might have. So you can see this kind of 3-layered structure here. Interestingly, Iceberg kind of has only 2 layers, right? So Iceberg, you have tables, and then you have namespaces on top of those. But within Polaris, we have a sort of, I've heard people use the term meta catalog. Basically, you have multiple catalogs within Polaris. And so maybe you have catalog ABC, which has 3 namespaces. And then maybe you have another catalog, which is federating, I believe that's the AWS glue symbol. So maybe that one is federating to glue. And so what typically happens is you have different groups of users who have access to different subsets of the data. Maybe this yellow user here only has access to the left catalog. Maybe this blue user only has access to one namespace. And then this green user has access to some mix. And this works pretty well. But eventually, what we find is users have little bits of non-Iceberg data. And they want to somehow group that data together and assign privileges on that data just like they do for their Iceberg data. And rather than have to introduce another catalog or another system for managing privileges, wouldn't it be nice if the Iceberg catalog would just let you add all of this data together and govern it together? So that is where the generic table feature in Polaris came along. So for Iceberg, we have a really nice specification. I mentioned there's some 20 APIs, right? Load table, drop table, and so forth. And we have a table metadata, I think it's called a schema, that tells you all the fields that a table has. But for non-Iceberg data, we don't really have that. For example, Delta and Hudi, there's not one standard way to represent a table over a REST API. So Polaris' solution is what we call generic tables. They're basically very similar to what you have in Hive. Actually, they're much simpler than what you have in Hive. It's basically just a table. It's got a format, it's got a location, and it's got some properties. In Hive, we had things like partitioning, for example, was built into the specification. But in Polaris, it's much simpler. So what problem does this solve, right? This lets you have a Polaris catalog and a compatible client, and that client can read and write, for example, Delta data. I should point out that we have a Spark client, a Polaris Spark client, which is different from the Iceberg Spark client. It's in the Polaris repo, but that's not the focus of the talk today. I do want to point out, though, the way it works is essentially spark.read.format.load. So any format that Spark recognizes will work with that same data stored in Polaris. So it means you could create, for example, a Pymon table or, Kafka topic or whatever, and stick it in Polaris, and you could receive some level of governance over that data and some ability to read and write it specifically with Spark. We also have a PR in the Trino community, so if you know anybody on Trino, help us get that approved. But essentially anything Spark is what we work with right now. But this doesn't fully solve the problem here, right? What if the Spark client writes a Delta table, but then somebody else comes along with an application that only works with Iceberg tables? Maybe 99 of your tables are Iceberg, and the client works with those 99 tables, but there's one Delta table. And suddenly they're not sure if they want to use Iceberg, and you have to do some kind of conversion. Maybe it's the other way, right? Maybe you've been using Iceberg. Thank you for using Iceberg. But you have one application that, for whatever reason, doesn't work with Iceberg. It needs data in another format. And so generic tables have opened the door for multi-format lakehouses on top of Apache Polaris, but there's not really any unification across formats. So in a way, we almost made the problem worse, right? Because now we let you create this weird spider web of clients and formats. But our real goal is that the client should just go to the catalog and say, I want to read a.b.c, and it should just be able to do that, right? It shouldn't have to think about what format that data is in and how that might interoperate with other formats. It should just be able to load the table. And so they can point everything at the catalog, but then they get back a different response, and so it kind of becomes the client's responsibility to parse the format. So how do we solve this problem, right? That's what the talk is about. We will introduce this feature called a table converter to Polaris, wherein, for example, an Iceberg client can tell Polaris, hey, I want to load an Iceberg table that's called a.b. And if Polaris sees that there is a delta table with the same name, but there's no Iceberg table, Polaris can trigger conversion to Iceberg transparently to that client. So as far as the client knows, there is an Iceberg table there, but really it's delta behind the scenes. The initial implementation of this converter is using Apache XTable, which is a project all about this, right? It's a project for converting between these lakehouse formats. And XTable specifically supports the formats Delta Lake, Apache Iceberg, and Apache Hudi. Recently, the XTable community introduced a REST service. So this was really important for Polaris to add this feature because it meant that we could now create like a remote converter within Polaris that makes a REST call and says that it wants to convert a certain table without you having to run conversion in the same JVM as your catalog. Right? A lot of the conversation we've had today about catalogs is about listing tables and loading tables. And so these operations are meant to be fast, right? We don't want to be doing heavy conversion inside the catalog because conversion sometimes can take minutes, maybe hours if you're really unlucky. So in this way, administrators can independently scale the conversion and the catalog and not have to worry about the latency costs of conversion. The way that you actually configure this, here we go. The way that you actually configure this in Polaris is with settings like this. So you say, for converting from Delta to Hudi, I want to use XTable. Maybe Delta to Iceberg, I want to use XTable. But I don't want any conversion in the other direction. So you can decide what kind of conversion you want to support. And this lets you sort of define for your lakehouse, what are the formats of record, right? What direction do you want to move in terms of guaranteeing that interoperability? In the event that conversion fails, right? So maybe that REST service I mentioned is down right now, or maybe it crashes, or maybe you've configured no converter. So in all of these cases, Polaris will just return a 404, right? So you tell Polaris you want to load Iceberg table a.b.c. Maybe there's a delta table called a.b.c, but it will fail to load because conversion is not possible, and so Polaris will say that Iceberg table does not exist. Now this is kind of unintuitive, right? I mean, there we go. You might wonder if this is really compliant with the Iceberg REST spec. Because Polaris is looking at a delta table and it's loading it through load table, right? The Iceberg REST spec says that load tables should only load Iceberg tables. But from the client's point of view, sorry, there's a bit of lag with the thing here. But from the client's point of view, it is an Iceberg table, right? I mean, he calls load table, he gets Iceberg metadata, he can write to the table, he can do all the other things you can do with an Iceberg table. So in a sense, we can really consider this an Iceberg table, even if in object storage, there is no Iceberg metadata currently. And this really comes back to the slides at the beginning of the talk today, where we see the catalog taking more and more responsibility farther down that stack. So in Iceberg v3, the client will assume that those metadata.json files are really there in object storage. Not all clients do this, but the Spark client does, for example. But there's this trend in Iceberg where maybe in v4, that won't actually be a requirement of Iceberg. So maybe there will be no metadata JSON files at all. We're getting in that sort of, we're going in that direction by only creating the Iceberg metadata just in time as it's needed. There are other APIs like list tables. So because we're treating this as an Iceberg table, it also means that we need to show this table when list table is called. And it could be the case that when you list the table, the Iceberg metadata still isn't there. But again, we're treating it as an Iceberg table because it can be loaded if you want to load it. So now we come to some of the future work. Many of you are probably watching this and hearing me talk about just-in-time conversion, and you probably already realized the obvious problem with this approach, which is that there's a lot of latency costs associated with conversion. Load table is supposed to be fast. It should complete in milliseconds. But if you do conversion, it could take minutes, and that's a pretty bad experience. So what we can do is we can combine this with the maintenance features inside Polaris and do conversion on the table before it actually gets loaded. You could do this when you first create the table, or you could do this anytime before load table gets called. Polaris has this table maintenance service on their roadmap. I think there's a couple PRs out right now. So in the future, we could create a table conversion action for the maintenance service to perform. So maybe every day at 5 o'clock, it does all these conversions. Or maybe you have some super smart AI that decides, this query is about to be run, so I'm going to perform conversion right now. If Polaris sees that the table has already been converted within some window, this window is configurable, so for example, 5 minutes, it won't re-trigger conversion. So essentially, the administrator can configure how much lag is allowed between formats. And so by pre-converting within that lag window, you don't see any latency added to your load table. Another piece of future work, rather, which is relevant to conversion, has to do with federation. So we see a lot of our users, both enterprise and open source, having this kind of fragmented catalog landscape. So maybe they have some part of their company that's using Databricks and they've got Unity Catalog and they're using Delta. Maybe some other part of their company is using Iceberg, but there's really old tables that are using like map files or CSV or whatever. And they really want to modernize their lakehouse. They want to standardize, right? Maybe they want to standardize on Delta, maybe they want to standardize on Iceberg, but it's really expensive to stop everything and convert all of this data and ensure that everything is converted correctly. But by combining Polaris's catalog federation and conversion, we can just put Polaris right there and point all the clients at the Polaris catalog, and no matter what format they used to be reading, they can now all read Iceberg, or they can all read Delta. So it allows you to kind of do a migration at your own pace, right? You can slowly convert the tables in the background, or you can slowly upgrade all the clients to all work with Iceberg, or maybe all work with Delta. And in the meantime, Polaris will perform conversion just in time as needed. As I said, right? So you can slowly standardize. You don't need to do everything at once, which makes migrations a lot easier. The last thing I want to call out, this is a short one, is that the table converter interface in Polaris is very simple. It just requires you to build a generic table, which is essentially a wrapper on top of a location and a format. So we're hoping that in the future, more implementations of the generic table, or rather of the converter interface, will come along. Snowflake already has one plan for our managed offering of Polaris, but we can foresee a situation where other table formats like Pymon require their own converters outside of what XTable can support. We're still finalizing the XTable support, so maybe some of it is possible to do within XTable, but I think for the time being, XTable is really focused on those 3 formats, right? Hudi, Delta Lake, and Iceberg. It also appears that Spark Connect could be a piece of low-hanging fruit. If you have a Spark cluster somewhere and you can just point the converter at that Spark cluster, maybe you can just do Spark read format from source and write to target. And that could be an easy way to implement a converter based on this new Spark Connect feature, I think in Spark 4.0. So that's pretty much all I have. If there's any questions, I'm happy to take them now.